Hi, welcome to Unit 3, Day 2, our first video that we'll be looking at in Unit 3. Okay, so you could call this Day 3.2. Alright, there was no video for Day 1. We did the vocabulary in class, and you may have even gotten a start on this notes packet on your own. This first part of our section is going to be talking about quadrilaterals. Quadrilaterals are polygons with exactly 4 sides. And we have some special quadrilaterals we want to consider. Parallelograms, rectangles, rhombi, which is the plural of the word rhombus, and then squares. And then we also have kites, trapezoids, and then trapezoids can be split up into isosceles trapezoids as well. So we've got a lot of different vocab terms here even, and I've given you the characteristics of each of these. And so I want you to take a little bit and read over these. There are many characteristics of each one of these. And the way this works as a flow chart is that if a rhombus is the quadrilateral we're looking at, it has all of its specific characteristics, but it also has all the characteristics of parallelograms, because a rhombus is one kind of special parallelogram. And it also is a kite, so it has all the characteristics of a kite also. Now I do want to show you this on kites. We have 2 pairs of consecutive sides that are congruent, okay? And since a rhombus has all 4 sides congruent, that makes that a kite also. And we have 1 pair of opposite sides, or sorry, 1 pair of opposite angles that are congruent. But then it says diagonals are, and then there's no symbol. In a kite, diagonals are perpendicular, just like in a rhombus. Okay, so put the symbol for perpendicular after that. Okay? And so we have rectangles. Rectangles have 4 right angles, and it has all the characteristics of a parallelogram. And squares have all the characteristics of both rhombus and rectangle. And so it doesn't have any unique characteristics of its own, but it has the shared characteristics of rhombi and rectangles. So if a quadrilateral is both a rhombus and a rectangle, then we call it a square. And then we have these characteristics for trapezoids. In a trapezoid, there's 1 pair of opposite sides that are parallel. Those are called the bases. Okay? And we have consecutive angles that are supplementary. Going back to what we know about parallel lines, these would be consecutive interior or same side interior angles if that's your transversal, so they have to be supplementary. Same thing with these 2. Now, if we have a trapezoid where the non-parallel sides, the sides that are not bases, we call those legs, if the legs are congruent, then it's an isosceles trapezoid, a lot like we had isosceles triangles. Okay, in this, diagonals would be congruent to each other, and then the base angles are congruent. This angle over here on the left is congruent to this one on the right, and at the top, the left is congruent to the right. So what we're first going to do is identify the most specific name or most specific type of quadrilateral based on what is given to us. Okay, in example A, all we are given is that the diagonals bisect each other. And here's how I know that. These tick marks mean that that's the midpoint of this diagonal. And then the double tick marks here mark that it's the midpoint of this other diagonal. Since the 2 diagonals intersect at each other's midpoint, we can say diagonals bisect each other. And so we want to look at these characteristics and find out which one of these have diagonals that bisect each other. Okay? And so we want to look for the diagonal words. In parallelograms, diagonals bisect each other. Well, that is all I know about the diagonals, so the best I can say is that this is a parallelogram. Okay? Now, once again, on part B, we have diagonals bisect each other, so we know it's a parallelogram, but they use the same markings for all 4 pieces here. So not only do the diagonals bisect each other, but they are congruent, and all 4 sides are congruent. Anytime we have all 4 sides congruent, we know that it's a rhombus. Okay? We do not know that the diagonals are perpendicular, though, but they would be in this case, because it's a rhombus. But we also know that the diagonals are congruent. So we look over at rectangle, and it says diagonals are congruent. So this figure is both a rhombus and a rectangle. Since it's both a rhombus and a rectangle, we need to call this a square. And then on part C, our quadrilateral only has one pair of parallel sides marked. And I know all of these look like they're the same figure. They look like a rectangle, but we don't go off of the way they look. We are going off of the markings. So the markings here show that we have one pair of parallel sides, and that is all. So that means it is a trapezoid. Okay. On example 2, I'm giving you the figure, the quadrilateral with the diagonals drawn, and I'm calling it a rhombus. And I want you to mark all of the characteristics of a rhombus on this. So you need to mark that there are 4 congruent sides. You need to mark that the diagonals are perpendicular. We do that with our right angle box. And we need to mark that the diagonals bisect each other, bisect opposite angles. Okay. But then we have an isosceles trapezoid. Okay? Now, an isosceles trapezoid, there are characteristics here that we need to mark. So I want you to do those on your own. Okay? And then bring them to class, and we're going to check the answers for number 2. So if you need to do this in pencil, so that if you need to fix anything, that'd be a good idea. But do these parts of example 2, and we will check those answers in class. Okay, let's go ahead and turn the page. All right. If you remember from yesterday, we talked about the definition of a polygon. A polygon is a closed plane figure with at least 3 sides. Now, we can further classify polygons in 2 ways, either as concave or convex, and then we can also classify it as regular or irregular. Okay? So concave versus convex, let's look at those definitions. Okay. Your definition for convex should have been something like this. To be convex, a polygon has to have all its interior angles less than 180 degrees. And that makes it concave if it is not convex. Okay, so if any angle is more than 180 degrees on the interior, then it's not convex. All right? And then for a polygon to be regular, a regular polygon has congruent sides and congruent angles. All sides are congruent, all angles are congruent, that makes it regular. So irregular just means not regular. Very simple definitions here. All right, and this leads us to being able to name different polygons based on the number of sides. Okay, if there are 3 sides, we call it a triangle. All right, if there are 4 sides, it's a quadrilateral. So these are prefixes. 5 sides would be a pentagon. 6 sides would be a hexagon. So you can write these in as you go. We'll check those in class, but most of you know these. 7 sides is hepta with a P, heptagon. 8 is octagon, 9 is nonagon, 10 is decagon, and 12 is dodecagon. You'll notice we skipped over 11. There is such a thing as an 11-sided polygon, but we very seldom will use that. I don't think we'll ever use that in this class, so we don't even bother naming it. It does have a special side. Anything beyond that, we just call an n-sided polygon, or if we're n is the number of sides. So if I said it had 52 sides, it would be a 52-GON, or a 52-sided polygon. So we're going to talk about the interior angle sum, meaning the sum of all the interior angles, and the exterior angle sum. And we're going to look at this part a little bit more later. But the interior angle sum is just the sum of all the interior angles. We're actually going to write a formula for that in that line in just a little bit. So what we're going to do is start to fill out this chart. All right? In a triangle, there are 3 sides. Okay? Now, when I draw a triangle, I cannot draw any diagonals of a triangle. There are no diagonals to draw. Diagonals connect a vertex to an opposite vertex, meaning a not consecutive vertex. Well, there are only 3 vertices to choose from. So, in a triangle, there's only one triangle I can create using diagonals. So, every triangle, you should remember, all 3 angles of a triangle add up to 180 degrees. You may remember that from a previous year, but I'm telling you that now. You need to know that the sum of the interior angles of a triangle is always 180 degrees. But if I draw a quadrilateral which has 4 sides, and I draw all the diagonals from one vertex, that creates 2 triangles. Well, the sum of the angles in this triangle is 180. The sum of the angles in this triangle is 180. If I add those together, I get 360. So then with a pentagon, there are 5 sides. Okay? And you kind of start to notice a pattern. As I add a side, I also add a possible triangle. So if you draw a pentagon and draw all the vertices that you can, or sorry, draw all the diagonals you can from one vertex, we get 3 triangles. 3 times 180 is 540 degrees. And so we kind of keep noticing this pattern, and what we're going to end up doing is developing that pattern based on n number of sides. And I want you to look at the relationship here. I'm going to kind of give you the rest of this so we can see how it works. In a hexagon, there are 6 sides. There would be 4 possible triangles there. 4 times 180 is 720 degrees. But a decagon, I'm going to skip a bunch here. Decagon's 10 sides. So how many triangles would I have? And you wouldn't have to draw that out to notice the pattern. In a triangle, there are 3 sides and only 1 triangle. 4 sides, there's only 2 triangles. 5 sides, there's only 3 triangles. 6 sides, 4 triangles. So we can always take the number of sides and subtract 2 to get the number of triangles created by those diagonals. So there'd be 8 triangles. 8 times 180 is 1,440 degrees total. If I added up all the inside angles, I would get that. So let's write these expressions. If there are n number of sides, where n represents any number of sides in your polygon, we always take the number of triangles as n minus 2. And so to get the sum of the interior angles, I take this number and multiply it by 180. So n minus 2 times 180 is the expression for the interior angle sum. So that is our formula. N minus 2 times 180 for interior angle sum. Okay, we are going to look at the exterior angle sum in class a little bit more, so we're going to hold off on that. So we're going to start filling this out. And we won't get through all of the notes in the video. We will need to finish the notes in class. Okay, but I want us to start to fill these in. So if there are numbers of sides given here, we need to give a proper name for it. 5 sides would be a pentagon. The interior angle sum for a pentagon is 540 degrees. We just did that in the previous chart. So if this was a regular polygon and all of the 5 angles were the same measure, what would the individual interior angle be? Well, to do that, we just take 540 and divide it by 5, because there are 5 of those interior angles, we get 108 degrees. So I would like for you to do the same thing for if there are 12 sides, 23 sides, and then just the expression using n to finish this part of the chart. The individual exterior angle we are not going to do yet. We will do that part in class. Okay? And then we will finish the rest of these examples in class. And we will take a look at some other terminology for triangles specifically in class.